Okay, so for this one, we're finding the mean of a binomial distribution, and the mean is n times p. N is the number of trials, which is 70, and p is the probability of success, which is 0.4. So if we do 70 times 0.4, you get 28. And for the standard deviation, you're going to do the square root of n, which is 70, times 0.4 times q, which is the probability of failure. Remember, the two probabilities here, total probability always adds up to 1. So if you take 1 minus 0.4, you would get 0.6. So your standard deviation is 4.1. And it actually is a longer decimal place, but we're rounding to the tenths. Okay, number 8, consider a Poisson probability distribution with a mean of 2.8. So here, and I don't know if y'all have Bookshelf, but you can pull it up in your e-text. If you go to the appendix, and I think I have the appendix pulled up. You're looking for a Poisson distribution table, so you'll have to scroll down. The first table, I believe, is your binomial. Poisson looks a little bit different. It's a wider type table. I think I went too far. Let's see. Yeah. Okay, so that is a table we don't really use. So let me just kind of have to scroll until you find it. That's a F distribution. This may be it. Nope, T. This is the normal distribution, which we use a lot for our z-scores. So that's where that is. Well, I thought it was on down. Maybe it's before normal. Alright, I'm going to pause it and find it and then start recording. Okay, so you're looking for the mean. Lambda is the, if you look at your formula, lambda is the same thing as the mean. I'm having issues with the table this morning. Okay, there's Poisson. So you're going to go to 2.8 across, because that's lambda, which is equal to your mean. And then your degrees of freedom is 21 minus 1, because n is 21, I believe. Hold on, let me make sure that's right. No, we're looking at, sorry, we're not doing degrees of freedom here. We're looking at x. X is 5. So go to 5 and go to 2.8, and you'll see that the probability is 0.0872. So for A, 0.0872. Alright, and then for B, the probability that x is greater than 6. So we have to use the complement rule here. We have to say 1 minus all the probabilities of 6 or less. So let's look and see. 6 or less would be 0.0407 plus all the ones below it. So I have written those down. 0.0407 plus 0.0872 plus 0.1557 plus 0.2225 plus 0.2384 plus 0.1703 plus 0.0608. And I think we're rounding to 4 decimal places here. So 0.0244. And then the probability that x is less than or equal to 3. If you go there to 2.8, find 3. It can be less than or equal to 3. So 3 and all the way to 0, 3, 2, 1, 0. Add those together. Okay, so we're going to do 0.2225 plus 0.2384 plus 0.1703 plus 0.0608. And we're going to round, I'm going to round to 4 again, even though it didn't really tell us. 0.6920. So there is B, and then there's C. Okay, the last problem. Determine the Poisson probability distribution with lambda equals 5.5. Determine the mean and the standard deviation. Well, the mean is equal to lambda, so that part is easy. The mean is 5.5. Then the second part, the standard deviation, well, the formula here is for the variance, and the variance is equal to lambda as well. So to get the standard deviation, you have to take the square root. So since the variance is equal to lambda, you're going to take the square root of lambda, which is 5.5. Okay, and we're going to round here. Let me see what we rounded to. Normally they will tell you what to round to. I just forgot to put that on there. 3 decimal places. Okay, let me know if you have any questions.